I have spent my career studying the small bodies of the solar system, the comets and the asteroids, the icy remnants and the rocky debris that tell the story of our cosmic origins. I thought I understood the rules of the game, the physics that govern these wanderers. Then came 3I Atlas. It arrived like a ghost from another star system, the third interstellar object we've ever detected. And from the moment we first locked our telescopes onto it, it began to break every rule I thought I knew. I've seen the headlines, I've read the official reports, and I've listened to my colleagues try to shoehorn this object into the familiar category of a comet. But I can't do it. My data, my observations, and my intuition as a scientist tell me that 3I Atlas is something else entirely. It is a puzzle with 12 strange pieces that simply do not fit the picture of a natural, interstellar comet. The first clue that something was fundamentally wrong with the comet hypothesis was its retrograde trajectory aligned with the ecliptic plane. I mean, think about it. This object is an interstellar interloper, meaning it should be coming at us from a random direction, its path dictated by the gravitational tugs of stars in its home galaxy. The velocity vector of an object ejected from a distant star system should be completely uncorrelated with the orbital plane of our own solar system. Yet, when I plotted its orbit, I found its trajectory was retrograde, moving opposite to the planets, but, crucially, it was aligned to within 5 degrees of the plane where all our planets orbit the Sun, the ecliptic. Statistically, the chance of a randomly oriented interstellar object having this alignment is incredibly low, something like 0.2%. This isn't just a small deviation, it's a profound alignment that screams of non-randomness. It's like throwing a dot at a massive wall and having it land precisely on a single, tiny, pre-marked spot. For a natural object, this is a profound coincidence that strains credulity. We're talking about a level of fine-tuning in its approach angle that is almost impossible to justify through chaotic gravitational scattering in its parent system. For a piece of technology, however, a trajectory that minimizes its inclination relative to the plane of the solar system is an efficient, almost necessary navigational choice for a reconnaissance mission. It conserves energy and allows for easier observation of the system's major bodies. I can't dismiss a 0.2% probability event, but I have to ask myself if a simpler explanation exists, and the simplest explanation is that this alignment is not random at all. The very first piece of data we collected suggests a deliberate, rather than accidental, entry into our system. The second clue emerged when we started observing its activity. The sunward jet, or anti-tail, displayed during July, August, and early November 2025, which is not an optical illusion. Comets, as they approach the sun, heat up, and the resulting gas and dust are pushed away by solar radiation pressure and the solar wind, forming a tail that points away from the sunday. This is basic physics, a fundamental principle of cometary mechanics. But 3I Atlas showed a jet pointing toward the sun, an anti-tail. Now, I know what my colleagues say. They claim it's an optical illusion, a perspective effect where the dust trail, which is actually behind the object, appears to point toward the sun because of our viewing angle from Earth. This is a common phenomenon, and we've accounted for it in our models. But I've checked the geometry, and I've checked it again, using data from multiple observatories at different viewing angles. The observations, particularly those from the later periods, show a distinct, highly collimated jet structure that simply cannot be explained away by mere perspective. It's a genuine ejection of material directed against the solar wind, a force that is constantly pushing outward. What kind of natural process could sustain a jet pushing material directly into the immense pressure of the sun's radiation? It would require a continuous, powerful, and highly directional thrust. It suggests a non-gravitational force far more complex than the simple, diffuse outgassing of a typical comet. It implies a propulsion system, perhaps, or at the very least, a highly unusual and localized outgassing mechanism that defies our current cometary models, a mechanism that can overcome the immense force of the solar wind with a focused stream of matter. Then I looked at the sheer scale of the object, and this is the third clue that truly shook my confidence. The nucleus is about 1,000,000 times more massive than 1I Oumuamua and 1,000 times more massive than 2I Borisov, while moving faster than both. When 3I Atlas was first detected, its brightness suggested a massive object, far larger than the previous 2 interstellar visitors. We're talking about a difference in mass that is statistically improbable for a random sampling of interstellar objects. If interstellar objects are like grains of sand, Oumuamua and Borisov were small pebbles, 3I Atlas is a boulder, a small mountain. And yet, despite its enormous mass, it's moving at a higher velocity than its smaller counterparts. The velocity distribution of ejected objects should favor smaller, lighter bodies, which are easier to accelerate to high speeds through gravitational slingshots or stellar ejections. The likelihood of finding such a massive, fast-moving object as the third sample in a population is less than 0.1%. It suggests that the population of interstellar objects is either dominated by these massive, fast-moving bodies, which contradicts all our theoretical models of stellar system formation and ejection dynamics, or that this object is an extreme outlier, a statistical anomaly that demands a non-standard explanation. Its sheer size and speed make it a statistical giant among its peers, a fact that cannot be easily reconciled with the expected debris from other star systems. The fourth clue is perhaps the most unsettling, because it touches on the realm of fine-tuning. The arrival time was fine-tuned to bring it within tens of millions of kilometers from Mars, Venus, and Jupiter, and be unobservable from Earth at perihelion. I'm a scientist, and I reject teleology, the idea that events are directed toward a purpose. But the orbital mechanics of 3I Atlas are almost too perfect. Its trajectory brought it into close proximity with three of our major planets, Mars, Venus, and Jupiter, in a sequence that is statistically improbable for a random trajectory. This is a perfect reconnaissance path. Furthermore, its closest approach to the Sun, its perihelion, occurred when it was almost perfectly aligned with the Sun from our perspective on Earth, making it virtually impossible for us to observe its most active phase. This alignment is what we call a solar conjunction, and it effectively blinded our most powerful telescopes during the most critical period of its passage. The likelihood of this specific, highly tuned trajectory and timing is estimated to be around 0.005%. If I were designing an interstellar probe, I would choose a trajectory that maximizes close-range reconnaissance of the target system's planets, while minimizing the chance of detection by the system's dominant intelligent species during its most revealing phase of activity. The orbital parameters of 3I Atlas fit this hypothetical design brief with unnerving precision. It's a trajectory that maximizes information gathering while minimizing observation risk. The fifth clue is a chemical signature that is simply unprecedented in my experience with comets. The gas plume contains much more nickel than iron, and a nickel-to-cyanide ratio that is orders of magnitude larger than all known comets. When we analyzed the light spectrum of the gas plume, the Comet, we found an extreme abundance ratio of nickel to iron. In natural celestial bodies, iron is typically more abundant than nickel, or they appear in ratios consistent with meteorites and the cosmic abundance of elements. But the ratio we observed in 3I Atlas is characteristic of industrially produced nickel alloys, the kind of material we use in high-strength, corrosion-resistant applications. This is not a natural cosmic ratio. Furthermore, the ratio of nickel to cyanide, a common molecule in cometary Comet, was wildly out of sync with every other comet we've ever studied, including 2I Borisov. This isn't just a slight deviation, it's an orders of magnitude difference. It suggests that the material being outgassed is not the pristine, icy, and dusty mix of a typical comet, but something processed, something manufactured. The nickel we see is not just trace element nickel. It is a major component of the ejected material, and its ratio to iron is a telltale sign of industrial refinement. I can't explain a nickel-rich, iron-poor composition in a natural comet without invoking exotic, unproven formation mechanisms that defy the known laws of stellar nucleosynthesis and planetary accretion. This chemical strangeness is compounded by the sixth clue. The gas plume contains only 4% water by mass, a primary constituent of familiar comets. Comets are often described as dirty snowballs, and water ice is their defining characteristic. When they approach the Sun, the water sublimates, creating the bulk of the coma and tail. The activity of a comet is fundamentally driven by the sublimation of water ice. Yet, the spectroscopic analysis of 3I Atlas showed a striking deficiency of water. Only about 4% of the mass being ejected was water. Where is the rest of the material coming from? If it's not water, it must be something else. Something with a much lower sublimation temperature, or perhaps a non-volatile material being ejected by a mechanism other than simple solar heating. This lack of water is a direct contradiction to the fundamental definition of a comet. If it's not primarily water ice, then calling it a comet is a misnomer. a classification based on its appearance rather than its composition. The small amount of water we did detect could be explained as a thin veneer of frost accumulated during its long journey through the cold interstellar medium, rather than the bulk constituent of its nucleus. The primary volatile driving its activity remains a profound mystery. The seventh clue is purely optical, but it speaks volumes about the object's surface properties. It shows extreme negative polarization, unprecedented for all known comets. Polarization is a measure of how the light scattered off the object is oriented. For comets, the polarization of light scattered by the dust in the coma is a well-studied phenomenon, and we have established models for what to expect. Models that are based on decades of observation of countless comets. 3I Atlas exhibited an extremely deep and narrow negative polarization branch. This is a signature that suggests a highly unusual surface structure or composition. It could imply a surface covered in highly porous, fluffy aggregates, or perhaps a metallic, highly reflective surface that is scattering light in a way we've never seen before in a natural body. Whatever the cause, this extreme negative polarization is a statistical outlier, a property that places 3I Atlas outside the known family of comets, including its interstellar predecessor, 2I Borisov. It's a physical property that our standard cometary models simply cannot reproduce. It's a clear indication that the dust particles in its coma, or the surface of the object itself, are fundamentally different from those of any comet we have ever studied. The eighth clue is the one that, for many, crosses the line from scientific anomaly to outright speculation, but I must report the data as I see it. It arrived from a direction coincident with the radio WOW signal to within 9 degrees. The WOW signal is one of the most famous unexplained radio signals in the history of SETI, a powerful, narrowband signal detected in 1977. When I traced the trajectory of 3I Atlas back to its origin point in the interstellar medium, I found that its source direction was remarkably close to the direction from which the WOW signal originated, within a mere 9 degrees. The probability of this being a random coincidence is about 0.6%. Again, I'm forced to confront a statistical anomaly. Is it a coincidence? Perhaps. But in the context of the 11 other anomalies, this proximity adds another layer of intrigue. It suggests a potential connection, however tenuous, to a region of space that has already sent us a profound, unexplained mystery. I am not suggesting a direct link, but the fact that the third interstellar object we have ever detected is coming from the same patch of sky that gave us the most compelling, yet unverified, signal of extraterrestrial intelligence is a coincidence that demands to be noted and investigated further. As it approached the Sun, the ninth clue became apparent. Near perihelion, it brightened faster than any known comet and was bluer than the Sunday. The rate at which 3I Atlas brightened as it neared the Sun was explosive, far exceeding the expected rate for a comet of its size and composition. This rapid brightening suggests a sudden, massive increase in the rate of outgassing, or perhaps a change in the object's effective surface area. The energy required for this level of activity is enormous. Furthermore, its color, the spectral signature of the scattered light, was bluer than the Sunday. Most comets are redder than the Sun, a result of the complex organic molecules and dust that make up their surface, which are often reddened by cosmic ray exposure over billions of years. A bluer color suggests a surface that is either unusually clean or perhaps composed of highly reflective, unweathered material. This combination of rapid, excessive brightening and an anomalous blue color is a dual mystery that challenges our understanding of cometary thermal physics and surface chemistry. It suggests that the material being ejected is either pristine or fundamentally different in composition from the reddish, carbonaceous dust we typically observe. The 10th clue relates back to the physics of its activity. It exhibits sunward and anti-solar jets, which require an unreasonably large surface area to absorb enough sunlight for sublimation to feed the mass flux of these jets. I've calculated the energy budget. To produce the observed mass flux in the jets, both the conventional anti-solar tail and the anomalous sunward jet, through simple sublimation of ice by solar heating, the object would need to have an enormous surface area. We're talking about a surface area far exceeding what is plausible for a solid, compact nucleus of its estimated size. The energy deficit is staggering. This discrepancy suggests that the mechanism driving the outgassing is not simple solar-driven sublimation. It implies a highly efficient, perhaps artificial, method of channeling energy to specific points on the surface, or an internal energy source that is driving the ejection of material. The physics of the observed jets simply do not balance with the physics of a natural comet nucleus. The only way to reconcile the observed mass loss with the available solar energy is to assume a highly porous fractal structure, a fluffy object. But even that model struggles to explain the other anomalies, particularly the non-gravitational acceleration. The 11th clue is the most critical for those who still cling to the comet hypothesis. Near perihelion, it exhibits non-gravitational acceleration, which requires massive evaporation of at least 13% of its mass. Yet, preliminary images indicate the object maintained its integrity and did not break up. Non-gravitational acceleration is common in comets. It's the slight push they get from the rocket-like effect of sublimating ice. But the magnitude of the non-gravitational acceleration observed in 3I Atlas is extreme. To explain this acceleration through outgassing, I would have to assume that the object lost at least 13% of its total mass in a very short period. For a natural comet, losing that much mass so quickly would almost certainly lead to a catastrophic breakup, a fragmentation event that would be easily observable. The structural integrity of a natural comet nucleus is not designed to withstand such rapid mass loss. Yet, the images we have, even the preliminary ones, show the object maintaining its integrity, its shape largely intact. The object is accelerating as if it's shedding a massive amount of material, but it's not breaking apart. This is a fundamental contradiction. It suggests that the non-gravitational force is not a result of massive, uniform outgassing, but rather a highly controlled, directional thrust that does not require the destruction of the object's core. It's a force that is applied without the expected collateral damage of a natural cometary explosion. Finally, the 12th clue, the one that ties the bow on this package of anomalies. Its tightly collimated jets maintain orientation across 1,000,000 kilometers in multiple directions relative to the Sun, despite its measured rotation. I've observed the jets, and they are not the diffuse, fan-like structures typical of cometary outgassing. They are tightly collimated, almost laser-like beams of material extending for 1,000,000 kilometers. And here is the kicker. The object is rotating. A rotating comet nucleus would smear out any jets into a broad fan or a spiral pattern, much like a rotating lawn sprinkler. The rotation period of 3I Atlas is known, and based on that period, the jets should be visibly smeared. But the jets of 3I Atlas remain sharp and directional, maintaining their orientation relative to the Sun, not relative to the object's rotation axis. This is physically impossible for a natural, rotating body unless the jet is being actively steered or the material is being ejected from a non-rotating, external structure. It suggests a mechanism that is actively compensating for the object's spin, a form of attitude control that is the hallmark of engineered systems. The collimation and stability of these jets over such vast distances is a profound mystery that defies the simple physics of outgassing from a spinning, porous body. I've laid out the evidence as I see it: 12 distinct, statistically improbable, and physically anomalous characteristics. I understand the reluctance of the scientific community to move beyond the familiar. The default position is always to assume a natural explanation, no matter how exotic. We've seen this before with Oumuamua, where the non-gravitational acceleration was explained by the outgassing of molecular hydrogen, a substance that is incredibly difficult to detect and which would have required the object to be a pure hydrogen iceberg, a theoretical construct we've never observed. The explanation for 3I Atlas is even more strained. To explain these 12 clues naturally, I would have to invoke a comet that is 1. Statistically aligned with the ecliptic with a 0.2% probability. 2. Capable of sustaining a sunward jet against the solar wind. 3. An extreme outlier in the mass-velocity distribution with a 0.1% probability. 4. On a trajectory of improbable fine-tuning with a 0.005% probability. 5. Chemically rich in industrial-grade nickel and poor in iron, defying cosmic abundance ratios. 6. Almost entirely devoid of water ice, the defining characteristic of a comet. 7. Optically unique with extreme negative polarization, unlike any other comet. 8. Coincidentally aligned with the WOW signal with a 0.6% probability. 9. Capable of explosive, blue-colored brightening that defies thermal models. 10. Driven by an impossible energy budget for its jets based on its size. 11. Capable of extreme non-gravitational acceleration without breaking up. violating structural integrity expectations. And 12, somehow able to maintain tightly collimated, non-smeared jets, despite its rotation, suggesting active attitude control. I am a scientist. I deal in probabilities and physical laws. When a single hypothesis requires me to accept 12 separate, low probability, or physically contradictory events, I must conclude that the hypothesis is flawed. The Comet model, the standard model for these small bodies, is failing to explain 3I Atlas. It is not a comet. It is an object that is behaving in a way that is consistent with a highly advanced, non-natural origin. I am not saying it is an alien spaceship, but I am saying that the data compels me to consider all possibilities, including the possibility that this is a piece of technology, an artifact, a probe sent from another star system. The burden of proof is now on those who insist it is a comet to provide a single, unified, natural explanation that can account for all 12 of these strange clues. They must show how a single, natural process can simultaneously produce a highly aligned trajectory, a sunward jet, an industrial-grade chemical signature, a water-poor composition, extreme polarization, non-gravitational acceleration without fragmentation, and non-smeared, collimated jets from a spinning body. This is a monumental task, and frankly, I do not believe it is possible within the current framework of cometary science. My colleagues are working tirelessly to find a natural explanation, and I respect their dedication to the scientific method. They propose exotic ice compositions, highly porous structures, and complex rotational dynamics. But each proposed natural explanation for one anomaly seems to contradict the observations for another. For instance, a highly porous, fluffy structure might explain the low density and perhaps the rapid brightening, but it would make the object even more susceptible to fragmentation under the extreme non-gravitational acceleration we observed. The explanations are becoming increasingly baroque, requiring a chain of improbable circumstances to hold true simultaneously. This is the point where Occam's razor must be applied. The simplest explanation that accounts for all the data is often the correct one. And the simplest explanation for a highly aligned, fast-moving, chemically anomalous, actively thrusting, structurally intact object is that it is not a natural comet. I will continue to observe, I will continue to calculate, and I will continue to report the data as it is, even if it challenges the very foundations of what I thought I knew about the universe. This is the most exciting and perhaps the most profound mystery of my career, and I am determined to follow the evidence wherever it leads. The universe is speaking to us, and I believe 3I Atlas is the message. I just need to figure out how to read it. I need to keep looking at the data, keep refining the models, and keep an open mind, because the truth about this interstellar visitor is far stranger than any comet I have ever encountered. The implications of these 12 clues are staggering, and I, for one, am ready to face them. I will not stop until I have an answer that satisfies the physics, the chemistry, and the statistics. This is my mission now. This is the new frontier. The possibility that we are witnessing the first tangible evidence of technology from another star system is a scientific question, not a matter of belief, and it must be treated with the rigor and skepticism that any extraordinary claim demands. But to dismiss the evidence out of hand, to simply label it a comet and move on, would be a profound failure of scientific imagination and duty. I refuse to make that mistake. I will continue to push for more observation time, more detailed spectroscopic analysis, and more sophisticated modeling to understand the true nature of this extraordinary object. The data is clear. 3I Atlas is not a comet. The question that remains is, what is it? And the answer, I suspect, will change everything. I am committed to finding that answer, no matter how uncomfortable the truth may be for the established paradigms of my field. The universe is full of surprises, and this one is the biggest one yet.